Hey there folks, I'm Raj and welcome back to our series on running Apache Airflow. In today's video, we are shifting focus to securely managing your secrets for Airflow using AWS Secrets Manager. But here's the catch. We are going to do it locally so that you can develop and test without incurring AWS costs. Shout out to Bruno who suggested this video or this topic in the comments of a previous video. Managing secrets securely is a critical part of any production system. AWS Secrets Manager is a popular solution that offers centralized, secure storage for sensitive data like database passwords, API keys, and tokens. Airflow can be configured to use AWS Secrets Manager as a backend so that your DAGs and operators can fetch secrets securely at runtime. However, AWS costs can add up if you're just experimenting. That's why today we are going to simulate Secrets Manager locally using LocalStack. We are also going to run the MWAA local runner that we have used before. Though one caveat this time, we are going to create an easy way to change the configurations on the base image. The script included in the repo is pretty basic and we want to tweak that to meet our expectations. Hence, instead of worrying about building our own image and then maintaining an image repository, we are going to just use Docker Compose in our setup, which would allow us to easily build the image locally. Before diving into setting this all up, let's talk briefly about how this is achieved, as this feature is actually broader than just AWS Secrets Manager. Apache Airflow allows you to use different backends provided by different community providers. And also you can roll out your own. I'll add a link in the description below to the documentation. As we already spoke earlier, we are going to look into Airflow's integration with AWS Secrets Manager in this video. So as we spoke about, for this particular setup, we are going to use Docker Compose. So make sure that that's installed on your machine. For the AWS MWAA local runner, what we are going to do is we're going to use a submodule in our repository so that it makes it easier for us to just pull in new changes whenever we need to. What we are going to do is we're just going to reference that repository and build a Docker Compose file based on the image that's defined in that repository. Yeah, and just modify certain configurations that we would need to update for Secrets Manager. So the first command that we would need to run is git submodule add, then the repository address. What that ends up doing is it just clones the repository in your git repo, and then you would have like a new file called git submodules or git modules. And if you look at that file, you can see the URL of the submodule. The advantage of using something like this is the next time AWS publishes a new version, we could come in here and just update the submodule, and that automatically fetches the new version for us. Let's look at all the files that are present in that repository. So we can see that there is a DAGs folder, DB data folder, then requirements folder. Because we would be using our own Docker Compose file, we'll just be skipping those and we won't be touching the folder inside these. So make sure whenever you're changing something, don't add a DAG in this particular folder. We'll still be following our old DAGs folder that's in the root of the repository. Now that we have this repository cloned on our local machine, let's create a Docker Compose folder. I've already gone ahead and done that, and let's look at the Docker Compose file which we have present over here. Let me increase the font here. So basically what I did was I just copy pasted the Docker Compose file from the local runner. You can see over here there are multiple. The one which I copy pasted is local because that includes the configuration for local executor. Now that in my Docker Compose directory, I updated the paths so that it uses the DAGs folder that's present in the root of the repo, as well as Airflow requirements folder that's also present in the root of the repo. You will also notice one additional container over here that's LocalStack. This container is required for us because we are going to run Secrets Manager on this container. The only port that this container needs is 4566 because that's where we are going to reach for loading or communicating with Secrets Manager. One thing to notice in this Docker Compose folder is a folder called volume. I've added this in git ignore because like we don't need to track that in git. Another configuration that I missed talking about is this Airflow config. Now this file is very much required because this is the configuration where we actually change the secrets backend. So if I go ahead and open the file and search for secrets, you can see that I've changed the secrets backend to be AWS Secrets Manager, and also added a bunch of arguments that would be required, especially the important ones being this connection prefix. So any secrets that we create in Secrets Manager should start with Airflow, a backward slash, and connections. A few other important configuration in this particular arguments is the region name, access key ID, access secret key, and AWS endpoint URL, because we need these variables for letting Secrets Manager know that we are using LocalStack and not to look for like AWS configuration in any other environment variables. So once you have this, once you have copied all the configuration, you'll have to go in the Docker Compose folder and then run Docker Compose up. Running this starts up all the stack, and now you can go in your browser and to localhost 8080, and you can see all the DAGs that were present in the root of the repository. If you run your Secrets Manager demo right now, it's actually going to fail, and the reason is you still don't have the secret. So what you would end up seeing is this log. Let me hop on here. You would see that it was able to connect to LocalStack, but then it wasn't able to find the connection itself. To set that up, I've added Pulumi configuration in the Pulumi folder. So I created a new stack called LocalStack in Pulumi. The important configuration for Pulumi to connect to LocalStack are these URLs. Make sure that you provide all these URLs in your Pulumi config, as well as the secret key and the access key. Also make sure that you are pointing to the right region and not using different regions in your Airflow config and your Pulumi. Looking at the Pulumi code, I've just being lazy, I just added the connection details right over here. But you should never store password in GitHub or in your Git repository or any version control repository for that matter. So instead you should have I should have generated a random password and use that over here. I'm going to stick with just hard coding it for now because I don't want to complicate the already complicated setup. As you can see over here, we are creating a secret version, a log group, just in case Airflow needs it, and yeah, that's it. To set everything up for Pulumi, what I'm going to do is go to Pulumi folder, go to LocalStack, Go to Pulumi up, refresh. Oh, I have a typo in refresh. Sorry about that. As you can see, Pulumi wanted to create those, so once I applied that, um, it was able to create the secret as well as the secret version. Now that we have all the components set up, we are just going to take a look at the DAG that we ran recently. So going to open that up. As you can see in the DAG, it does nothing. It's just using it's just connecting to Postgres that Airflow already has data in, and it's just going to read the names of the tables that are in the Airflow's meta database. And once it actually like reads that table, it's just going to print it out. Let's go to the UI and run the task and see what output it gives us. So this DAG passed. Let's take a look at list tables first. So we can see that it ran the ran the query, and no errors over here. It was able to leverage AWS connection and connect to the use the Secrets Manager backend and connect to LocalStack. Now in print tables, we can see all the tables that are available in the Airflow's meta database. So with this small example, we can see how we can leverage LocalStack to run Secrets Manager and then use Airflow's Secrets backend to connect to Secrets Manager and run your whole DAG locally. This is actually a great tool to have in your pocket because it allows you to iterate quicker and fail quicker and make sure that you can correct your mistakes in a quicker fashion. You don't have to like wait till you ship your code to earn like an AWS environment and then discover that things are going wrong. Thanks a lot for hopefully you have learned how you could leverage LocalStack and tie that with Airflow and use those connections together. And that's a wrap. Now you have MWAA running locally with LocalStack Secrets Manager, making development and testing much easier. This setup eliminates the guesswork, speeds up iteration, and ensures a smooth transition to production. If you find this helpful, don't forget to like and subscribe and drop a comment below if you have any questions or any feedback that you might have. I'm also starting an email newsletter where I'm going to share topics related to my YouTube videos in written format, some additional technical content, and also productivity tips that have helped me. I'm adding a link to the newsletter down below. Please subscribe to stay connected. Thank you and see you again in the next video where I'm going to cover looking at Airflow logs in LocalStack. Signing off for now. Have a great week and keep learning.